Welcome, dear audience, here at the Technical Forum of Hydrogen Fuel Cells Europe at the Hannover Messe 2022. Please get comfortable, get a nice seat. We still have some of the very nice, very comfortable seats. Drinks are in the house here, that should also help with getting comfortable. And what should also help is that the next topic is an interesting one. Talking about hydrogen storage control unit, which enables a sustainable mobility and beyond. So even more. So from Schaeffler Engineering, please welcome Systems Engineer Moses Kowski.
So, hello everyone. Welcome and thanks for joining our presentation. My name is Moses Kowski from Schaeffler Engineering. I'm engaged in the system development of the device I will present you today, the Hydrogen Storage Control Unit, which is our contribution for enabling a sustainable mobility and beyond. So, let's start. Here you can see the Schaeffler hydrogen chain, starting on the left with the hydrogen production by renewable energies and an electrolyzer, followed by storage and transportation in the middle. After the filling station, our applications follow on the right. These are software applications for hydrogen fuel cells and hydrogen internal combustion engines, as well as hydrogen storage systems with our Hydrogen Storage Control Unit in the short form HSCU. Coming to the HSCU, we thought about the targets of mobile hydrogen storage and came up with 4 key points. These are safe and reliable operation, which goes hand in hand with a proper safety monitoring, accurate stage of charge calculation to enable an efficient usage of available storage space, and last one, filling station communication, refilling handling, and monitoring. You can see our hydrogen storage control unit on the right, so this is the ECU. And you can see our HSCU implemented in a truck on the left, where it is connected to 4 individual hydrogen tanks right behind the driver cabin. Now you can see the detailed system configuration. Our HSCU is right in the middle in gray. On the left, you can see the filling station. On the right, you can see the hydrogen consumer, which can be a hydrogen fuel cell or alternatively a hydrogen internal combustion engine. Right above, you see the vehicle control unit, shown as VCU. And down below, you see the hydrogen tanks, again shown as 4 individual tank bottles. The control flow in this system goes from the HSCU to the system actors in the green dotted line. All system actors in this configuration are hydrogen valves. You can see the hydrogen flow in blue, and the hydrogen flow represents the hydrogen piping of the system, and it goes from the tanks to the consumer on the right, or from the filling station on the left to the tanks down below. Additionally, we have some signal and data flow shown in the gray dotted line. So, the HSCU will handle the communication with the filling station to enable a fast and efficient refueling of the system. Also, the HSCU will handle the complete communication with the vehicle, where the vehicle will send a supply request to the HSCU in order to get the consumer supplied. The HSCU is also capable to have a direct communication with the consumer itself. The HSCU gathers all pressure and temperature measurement points throughout the system. These are pressure and temperature in each tank bottle, as well as 2 pressure and temperature measurement points throughout the piping. Additionally, there's a hydrogen sensor around the system, which captures the hydrogen concentration in order to detect leakages for safety purpose. The HSCU is able to power up to 10 system valves, which are configured like up to 8 tank valves for a maximum of 8 tank bottles. an optional pressure regulation valve to modulate the pressure for the consumer needs. And last one, a shut-off valve, which is able to cut the hydrogen supply right before the consumer. And this works like kind of a redundancy with the on-tank valves to close the hydrogen flow fully if needed. You can find the short technical details on the right below the ECU. So this electronic control unit is made for compressed hydrogen and also liquid hydrogen storage systems. It's made for the usage in heavy and light-duty vehicles. It has an AUTOSAR 4.3.1 architecture, and it is programmable with the MATLAB Simulink toolchain. We can provide a functional safety classification up to ASIL C, depending on the system, and it is compliant to the cybersecurity ISO 21434. Our hydrogen storage control unit will be available in serious production as of Q4 in 2024. But in the meantime, how can you getting started with your hydrogen project? For your hydrogen project start, you can use our rapid control prototyping platform, Protronic Target Line, which you can see right in the middle of this slide. The Protronic Target Line is directly usable with our RCP toolchain. It has a physical modular design, including multi-rate. It's also programmable with the MATLAB Simulink toolchain, and you have a flexible definition of in and outputs fitting your particular system. You can rapidly use it on development or test, and you will have a smart and easy transfer from the Protronic Target Line to the series production ECU. Down below, you can see the software development cycle with the Protronic. Starting on the left, you can create your own function design and simulate your functions offline. You can implement your particular in and outputs fitting your system. You can generate the code, flash the software, test and validate your functions directly on your system with system parameter measurement and calibration. So with the Protronic, you are able to gain early system knowledge and proper degree of function maturity before jumping on the series production ECU. An example for that is shown here. This is the prototype of a hydrogen storage system where you can see 4 individual tank bottles in the right picture. These tank bottles are equipped with 4 on-tank valves, and all of these valves are connected with the hydrogen piping. Like in the configuration before, we have several pressure and temperature measurement points throughout the system, as well as the hydrogen valves, which all are connected to our Protronic Target Line. You can see in the left picture, bottom right. So the Protronic takes over the communication, measures pressure and temperature, also monitors them, and is able to power all system valves. With a configuration like this, you are able to have a running system early in your development. Let's come to the summary. Our hydrogen storage control unit provides complete storage control, monitoring, and communication. It is cybersecurity and up to ASIL C compliant. Our hydrogen storage control unit will be available in serious production as of Q4 in 2024. You can start your development right now using our RCP platform, Protronic Target Line, and our additional portfolio on hydrogen applications are generic software for hydrogen fuel cells and hydrogen internal combustion engines, as well as hydrogen testing facilities. For further in-depth questions, please meet us at the Schaeffler booth, E22, Hall 13. Thank you for your attention.
All right, warm applause, please. Wonderful presentation. And for the people here and the people at the live stream, We will be back in 4 short minutes, so please remain seated, stay comfortable. If you do want to continue the conversation with Schaeffler Engineering, I think you will be here for a little bit maybe, so you can ask your question live right here, or you can make your way to their booth, which is at E22. So that is roughly somewhere over there, and then 4 hallways back. So please stay comfortable, and we'll be back with you in just 4 minutes. Thank you.
Thank you.